Hi all. Today we'll be discussing the LeetCode problem of the day, find unique binary string. So you're given an array of strings containing n unique binary strings, and each of the string are of length n. So the array contains total n binary strings, and the length of the binary string is also n. So you have to return a binary string of length n that does not appear in this array of numbers. And if there are multiple answers, you can return any one of them. So for example, in the first example, we have the arrays as 0, 1 and 1, 0. So the array size is 2, and also the binary strings in them is of length 2. So out of all the binary strings of length 2, you have to return any one of them which is not present in here. So one of the example could be 0, 0. 0, 0 is a binary string of length 2 which is not present here. So you can return this, or you can also return 1, 1, since 1, 1 is also not present in this list. So these two are valid options, and since you can return any of them, so for this example, 1, 1 will be the output. So let's look at the second example. So again, it's 0, 0 and 0, 1, and here you have n equal to 2. So for this as well, there are two choices. You can either return 1, 1 or you can either return 1, 0. So 1, 1 is also a valid option. If we look at the third example, the array size is 3 and each of the string has length 3. So we have 3 strings which are already there, and you have to return another binary string of length 3 which is not present in this array. So one of the option could be all zeros, or you can also do 0, 1, 0 and so on. So one of the option is 1, 0, 1. Since 1, 0, 1 is not present in this, that could be our answer. So you can also return this, or you can return this, since there can be multiple options. Now coming to the constraints, n, which is the number array size, can be from 1 to 16, and of course the array size will be equal to n, which will be equal to the string length, and the string will contain either 0 or 1 because it's a binary string, and it is guaranteed that all the strings in the numbers will be unique, so there are no repetitions. Now let's go over the approach. So suppose let's take the third example where you have n equal to 3, and you are given an array which already has 3 binary strings in them, 1, 1 and 0, 0, 1. So one thing we can say is for n equal to 3, we have total 2 power 3 possible options for the binary strings. So for n equal to 3, we have total 8 choices. And amongst 8 choices, only 3 choices are listed down. So it is always possible that some of the options will be not listed here. So if we take the same example for n equal to 1 as well. So for n equal to 1, only one binary string will be listed here, but total choices will be 2 power 1, which is 2. So always the total number of choices will be greater than the n, because 2 power n is always greater than n. So that this proves that we can always find an answer. So now the real question is, among all the possible choices, how can we build the answer? So one possible way is, so suppose again in our example, n was 3. So you can simply iterate, like you can iterate 4 numbers. You can either iterate 0, 1, 2 and 3. So you can just iterate in these 4 numbers and try to see if any of the numbers are not present here. Then you can directly return it. So among these 4 numbers, it is guaranteed that one of the number will always be not present, because in this you have slots for only 3 numbers. So similarly, suppose you have n equal to 2 here. So you can just check for the number 0, for the number 1 and for the number 2. So basically for any n, you can just check the first n plus 1 numbers, and in that, of course, one of the number will not be present in the array, and you can return that. So this method will be a bit complex, and it will take a bit more time. So we'll try to see any simpler approach for this problem. So for n equal to 3, let me just write down the given strings. So first we have 1 1 1, then 0 1 1, and 0 0 1. So total you have 2 per 8 possible, 2 per 3 possibilities, which is 8 possibilities, amongst which only 3 are given. And you have to find one more string which is not in this. So what we can do is, to form the first bit, you can pick the first string. So in the first string, the first character is 1. So you can just set it as 0. So by doing this, this ensures that our answer will not be equal to the first string. Now moving to the second character. Now you can compare it with the second string. So since the second string is 1, you can set it as the opposite of this 1, which is 0. So this guarantees that our answer will not be equal to the second string because this character is differing. Similarly, to fill the last character, you can simply set the opposite of the first character. So again, the first character is 1, so I can set 0. So this ensures that my resulting string will not be equal to the third string also. So once we are done with this process, we have formed a string. And since each of the character differs with the position of each of the strings given in our array, so this makes sure that the string we formed will not be present in the array. So this is how we can form the answer. So let me just take another example so it will be a bit more clear. Maybe this time I'll take n equal to 4. So let's say my first string will be 1101 and second string 1000. Let's say third all ones, and 41101. Oh, I think this is repeating, so let me just change it to something else. Yeah. So for n equal to 4, we have these 4 strings. So again, we can repeat the same process. We have in an answer, it will be of size 4. So for the first character, I will try to differ it with the first string in the first character. So since it is a 1, I'll just set it as a 0. Now for the second character, I'll try to differ it with the second string in the second position. So, okay, by doing this, by putting 0 here, it is guaranteed that the answer is not equal to the first string. Similarly, here, since I have a 0, I can just put a 1. So this ensures my answer is not equal to this because it's differing at this position. So for the third string, I'll just check this is 1, so I'll set the opposite of it, which is 0. And for the fourth string, I'll check for the fourth position, I'll just check the fourth string. Here I have a 1, so I'll just set the opposite, which is 0. So finally, this is the string I have formed. And since we differed it in each position, it is guaranteed that this string will not be present in our array. So this is how we generate our final answer string. So before we proceed, I just want to run it through with our first and second inputs as well. So in the first input, we have 0 1 and 1 0. So the first position, I'll check with this string. It's a 0, so I'll put a 1. Now for the second position, this is a 0, so I'll set the opposite, which is 1. So this is what our answer is formed. So 1 1 is not present in this array. And by chance, 1 1 is also the answer. Now looking at the second example, I have a 0 0 and I have a 0 1 here. So these are the two strings which are given. So again, the same process. In the first string, I have a 0, so I'll set the opposite as 1. And in the second string, I have a 1, so opposite of 1 will be 0. So 1 0 will be my answer. So 1 0 is not present in this array. Now let's quickly code the approach. So let me just take a string builder in which we'll build our answer character by character. So string builder answer equal to string builder. So now let's just iterate on the array of strings. So how we do the iteration is when I equal to 0, I will look at this character and I'll just append the opposite of it to my answer. So for 1, it'll be 0. So next, when I equal to 1, I'll check for this character and I'll just put the opposite. And when I equal to 2, I'll check for this character and just put the opposite of it in our answer. So basically it will be like we are just iterating on the diagonal. So I can just check if sums of I dot current I, if the current character is a 0, then I'll just do answer dot append 1. And if the current character is a 1, then I'll just do answer dot append 0, just the reverse of it. And at the end, since we have the answer as a string builder and the function is expecting as a string, so we need to convert it to a string. So I can just do return answer dot to string. Okay, let me submit. Yeah, and it works. Finally, let's do time and space complexity analysis. Coming to the time complexity, we are just iterating on the array once, and for each iteration, we are just iterating on one character of a single string. So inside we are doing constant operation and we are just iterating over the length n. So time complexity will be order of n. And also here converting a string builder to a string is also order of n. So in total time complexity will be order of n. Coming to the space complexity, since we are declaring a string builder and its size will grow up to order length n, so space will also be order of n. I also have the code in Python. If anyone wants to view it, I'll add this in the description as well. And let's catch up in the next video.